I know it's day 4, so you've been hearing a lot about climate, and they've asked me to come and speak a little bit about geoengineering. Now, I don't have to go over this for you guys. You've all been basically, you've become familiar, right, with the basics of the climate system, greenhouse gases, the sun coming in, so forth, so on. So let's just talk. I just want to get a feel from the audience here. What are the ways you can think of about how we cool the planet? Like, what are the ways that you can go about doing it? Yeah.
Increased high clouds.
Increased clouds.
The reflected clouds.
Great. It was the same principle of like even just coming kind of shading in a way too, but increased clouds. Any other ideas people have heard about? Yeah.
Are you talking about ways we could actually manipulate or ways it doesn't? I don't understand the question.
Ways that we can cool the planet. So we have this problem with a hot planet, right? We have a greenhouse gas warmed planet, extra greenhouse gases.
And we can personally.
Oh, I'm thinking society in general. In general.
Human beings.
Yeah, yeah. Oh, but you didn't, okay, yeah, go ahead. Sequester carbon dioxide, right. So you had a presentation this morning about sucking the CO2 out of the air. So get that extra CO2 out of the air. So clouds, getting CO2 out of the air. What other ideas have people heard about? Anything else so far? Mirrors in space, that's another idea. Basically, almost anything you can think of, people are kind of thinking on the back of cocktail napkins right now, because this is basically where we're at with geoengineering. There's basically 2 main ways people are thinking about society in general trying to cool the planet. Now, let me just give a little aside first, which is, I'm not talking about let's reorganize our energy system so we use less fossil fuels. You've already talked about that. That is a whole other kettle of fish, a whole other ball of wax. I'm talking about methods that you would basically keep burning fossil fuels, or if you, for some reason, you couldn't stop burning fossil fuels. There's basically 2 main ways people are talking about under the name geoengineering. One is deal with the CO2, take it out of the atmosphere. And you've heard in the morning about a system to basically try and suck it out of the atmosphere. Then you still have to put it somewhere, right? You can't just keep it in a power plant. You got to put it somewhere out away from the atmosphere for it to actually affect climate. Because remember, going back to this picture, we need to get stuff out of the atmosphere if we want to try to cool the planet on a planetary basis. The second way is deal directly with the temperature, with the radiation balance. So things like the clouds idea, space mirrors. These are types of ways of trying to directly address the temperature of the planet by different types of engineering ways. So one is deal with the greenhouse gases, take extra CO2 out. The other is try to deal directly with the temperature. This diagram here is just you probably, can you see it, Mark, way in the back there? Or sort of? I'll just go through it a little bit. But this just gives you a sense of some of the, I didn't do that right. Okay. I just hit this thing and I wasn't sure. Okay, so this is just a little cartoon kind of diagram of some of the ideas that are out there right now under the name geoengineering. Space mirrors, somebody mentioned them up here. They're up at those little discs at the top of the screen there. And the idea would be to try to put some mirrors into space that would orbit the planet and try to reflect some of that radiation coming in from the sun, to try to basically block some of the sunlight from coming in. Things also like aerosols. On the upper right, there's this little airplane over here with a little cloud of dust after it. That idea comes from the basic idea of volcanoes. You've heard of Mount Pinatubo? Everybody heard of Mount Pinatubo? We know that when volcanoes erupt and they put a lot of sulfur particles into the atmosphere, they cool the planet for a year or so in some cases. We also know that even over cities where there's a lot of coal, or places where we're burning a lot of coal and you get coal dust in the atmosphere, it's a temporary cooling of the atmosphere there. So particles in the atmosphere can cool the temperature below. And so the idea would be, let's load up a bunch of supertanker airplane type things, fly into the atmosphere and unload these particles in the atmosphere and create a temporary cooling effect by having to put these particles into the atmosphere. That's different than cloud seeding. Now, somebody mentioned the cloud seeding idea. This little thing, I guess I can't walk over there, but it's basically this tube-looking thing coming from boats, 3 tubes there. This has actually gotten some funding. I just read about it recently from Bill Gates, millions of dollars. There's a company out there called Silver Lining. They want to do this, and they're going to probably get to because Bill Gates gave them some money. They're sucking up some of the surface seawater, pumping it into the atmosphere, and artificially creating clouds. And so that extra cloud cover is going to reflect some of that solar radiation coming in, and it's going to cool that way. That's the idea. Let's see, what other temperature-related ones are there? Okay, reflective crops. That's another idea. There it would be plant some certain types of crops that reflect more light into space. I mean, you all know about, like, if you're standing on a white square or a black square, or you have white clothes on and black clothes on, where are you going to feel hotter? You're going to feel hotter if you're wearing what color? Black. Same idea, right? If you paint your roofs white, if you grow crops that are kind of light colored, if you've seen Al Gore's movie, he talks about the ice and the polar caps being white and reflecting in how when they melt and they're darker. Yeah, you had a question?
Well, I was noticing the readiness
Yeah.
bars and what each of those years represent. So why are reflective crops so far into the future, like decades as opposed to like now? You know?
I don't know the exact reasoning, but my guess is it's a GMO type of, they're going to engineer crops to be still useful for food or some other purpose and also be lighter in color. That's just a total guess. But that this also, I'll go into the details of these little kind of subheaders and talk a little bit about society and how they're thinking about these too, but yeah.
My question has always been, particularly on the putting the sulfur particles into the atmosphere and the putting up of the salt crystals,
Yeah.
the
Mhm.
reflective clouds, and maybe even the mirrors. I mean, don't plants need sun for photosynthesis?
Yeah, they sure do. And don't we need sun for solar power and like these other things that we kind of use sun for? Yeah, and somebody here at NOAA, I think, actually just did a paper calculating the effect on solar power, for example. If you start reducing the amount of incoming solar radiation, how much solar power are you going to lose? Which is something to remember, and I'll just give away my bias right now. I'm pretty skeptical of a lot of these ones that have to do with manipulating the radiation balance. That's my own bias. Simply because I think there's a lot of consequences down the road that we just don't know. And there's a lot of people advocating for research right now, and maybe those will or will not solve some of those. But as we know, anytime we start manipulating things, there are things that happen that we don't know about down the road. That's one of them that we can tell right up front. Oh, less sun, okay, less sun for growing crops, less sun for solar power, things like that. Also less heat though, so.
When they've had those volcanic eruptions,
Right.
it has interfered with crops.
Yeah, yeah, exactly. Oh, so I should be repeating, I'm sorry. Yeah, she's saying that yeah, when we've had volcanic eruptions in the past, it's interfered with crops growing and so forth. And there's a lot of different interactions when you get into an Earth system perspective on these kinds of things. It's very tricky. All right, so then we can go to the types of things that have to deal with the carbon. Remember I mentioned there's sort of two aspects, and I know you've heard about the, is Dean here still? Or no, he went. Okay, but you've heard about this idea of artificially taking out CO2. Another idea is biochar. Anybody heard about biochar? It's kind of one of those things where there's like groupies of biochar sometimes. They come to conferences, they're really into biochar. I've noticed this about biochar. Anyway, biochar is basically actually a very medieval type of technology. People used to do this before. You burn wood or burn biomass in the absence of oxygen, or sort of try to get it as much in the absence of oxygen. You make charcoal out of it, and instead of just burning that charcoal then for fuel, you bury it. And that would be the idea, is trying to kind of convert biomass and get it really concentrated and buried in the ground and get that carbon away from the atmosphere. And that's basically the biochar idea. Artificial trees, you've heard a little bit. CO2 sucked out of the air, capture it, convert it into a form you can just store it underground. What other ones? Forestry, basic forestry. Obviously, we all know growing plants takes up CO2. Trees absorb CO2, and then you've got that carbon stored in the form of a tree, or roots, or leaves, and so forth. What's the problem with that in terms of the atmosphere? Place to grow forests. You're using the land for other things. What other kinds of things happen to forests?
They'll eventually
Decompose, goes back up. What do we have right now and going on in Colorado? Beetle kill, forest fires. These kinds of things are very subject to disturbance. We call it disturbance in ecology, right? So forests, they're good. They're pretty cheap, but you need land, as you mentioned, and you need and you've got that it's a temporary form of storage. I mean, obviously you can replant those forests, and over the long term you can keep them going, but they do eventually exude that carbon back into the atmosphere. Let's see what else we got. Let's talk about the ocean. Let's see, people know a little bit about, I talked about this at lunch actually with folks about the carbon cycle in the ocean, that there's a lot of plant growth at the top of the ocean, and then that decomposes and dies and carries a lot of carbon down to the bottom of the ocean. And that's the way the carbon cycle moves. It eventually gets into sediment, rocks, and so forth in the bottom of the ocean. People have proposed adding some extra fertilizer, basically, to the ocean to try to increase the algae growing in the ocean, suck up some of that additional CO2 with the photosynthesis of that algae, and have it sink, that carbon then eventually sink down to the bottom of the ocean. They've actually done about 12 or 13 large-scale ocean-going experiments now, and they so far have not seen this work the way they'd hope. In other words, they can get a bloom of phytoplankton. We call it a bloom. You put fertilizer on, you get this growth of phytoplankton, but whether it actually clumps up, sinks to the bottom, gets that carbon away from the atmosphere is a real open question that we don't know. And so far it doesn't look real promising in that way, but it's got its proponents. There's some folks out there who would like to try it. The other way is to think about just, if you have the air capture machine, capturing the CO2 into a tanker or something like that, and actually taking a pipe and sending CO2 down to the bottom of the ocean through a pipe, actually just at depth. You remember, you know about obviously we all know about this horrible oil spill going on right now. And one of the techniques that BP used to try to stem the flow, I think they put a mixture of water and other stuff, sludge type stuff they were trying to use to stem the flow of oil. But they had this problem with ice crystals forming and clathrates. It's basically like things solidify at really high temperature and pressure. And that's what happens if you put CO2, gas at this level, put it down under high pressure in the ocean at low temperature, turns into kind of almost like jello. It's sort of like a pool of sludgy jello that spreads out over the ocean and eventually would dissolve into the water. But that's another thing people are thinking about in terms of storing CO2 in the ocean. I'll just mention real briefly some of these other factors on here, talking about readiness. That's sort of a general ballpark figure of how ready are we to do this. Do we have the technology? Do we know how it works? Airplanes shooting letting go of stuff in the atmosphere from airplanes, pretty easy to do actually. We know how to launch airplanes, we know how to make sulfur particles, we can load them in an airplane and dump them out. Not that hard to do actually. Yeah, question?
But when you dump sulfur particles and make clouds, don't you create acid rain?
That's a good question, and people are concerned about it. It's a higher level than our normal weather systems are. It would be in the stratosphere rather than the troposphere. But it's a good question nonetheless, because we don't know exactly what adding that sulfur at that level would do, and where would it go. Presumably it would go somewhere. It would rain out at some point. But would it create acid rain in the way we think of it? I don't know. We don't, and that's again one of those areas they'd have to study. But it is kind of interesting. I mean, for decades we've been trying to get sulfur out of the atmosphere. It's kind of ironic as an environmental person to think, oh, we're going to add it to the atmosphere again. Was there another question? Or? Okay. So readiness, some of these are different types of readiness. Obviously trees, pretty easy to do, trees. Cost is another factor. How much is this really going to cost? Turns out the sulfur airplane thing isn't that costly either to do it. If we have some of the effects that somebody mentioned about, for example, disrupting crops, having other kinds of unintended consequences, those could be huge costs that those are kind of byproduct costs that we don't really know about at this time. Some of the flaws, there's a lot of potential issues that you could imagine. Did you have a question?
Yeah, I just wondered if you could tell me when this diagram was published in the New Scientist.
This, I think, was maybe in 2008 actually, or last year, 2008 or 2009. I've been trying to, this is on the web, this picture, and I tried to track the source, and I finally tracked it to New Scientist, but I didn't have a subscription on my computer, so I couldn't find the exact article, so I'm not sure. But it's a pretty good diagram because it's pretty current with a lot of the things that people are thinking. All right, so there, you can imagine there's like pros and cons to a lot of these different ones from a technical perspective. From the perspective of, do we know how to do it? How much is it going to cost? Is it actually effective? Those kinds of things. And people don't know a lot. And there's some groups that are really advocating for research into these types of technologies. As you can imagine, though, even research could be cause for concern if it's at a large enough scale to actually influence the climate or be testable in some ways. You know, it's going to have an impact at some level. And so there's different amounts of worry about that, I'd say, in different types of parts of society. Do you have a question? No? Okay. All right, so that's that. I just wanted to, this is probably hard to read from the back as well, but I'll show you this, describe it. This is from a recent Royal Society report in England. They did basically a preliminary assessment of geoengineering. And they came up with trying to categorize effectiveness and affordability, the two sort of concerns from a very basic perspective that people would have for doing this. And just bear with me a second. On the x-axis, we have affordability, of 6 being kind of more affordable, so it costs less, essentially, right? On the y-axis, we have effectiveness, so 0 meaning not very effective, you know, it's not going to work real well, to 5 being pretty effective. So on the upper right quadrant here, we have things like stratospheric aerosols. They're pretty cheap, and they're pretty effective, at least from what we can tell from basic physics and modeling and things like that. Down here on the lower left, things like surface albedo. So that would be like painting roofs in urban areas. You know, it might make you feel good and so forth, but there's just so little space covered by urban roofs when you really think about the whole planet. It's probably not going to be as effective. And maybe pretty expensive when you compare it to other things too. High effectiveness but low affordability, things like air capture, reflectors in space, things like that. In the middle, we've got a bunch of stuff like clouds, ocean fertilization, carbon capture and storage, things like that. Afforestation is over here on the right in that it's pretty affordable. How effective it's going to be, you know, it's kind of middling effectiveness. So this is really, it's kind of one of those basic cocktail napkin type of assessments of what we think about things right now. We haven't done a lot of experiments. People are dreaming up ideas and saying, well, this could work, maybe this will work. There isn't a huge research program really investigating this stuff right now. Yeah, question?
The whole thing about, you know, using the ocean to put even more carbon dioxide in,
Right.
the ocean is already acidifying.
Right.
And, you know, I mean, I would think that the ocean would be totally off limits.
Good question. Yeah, she was asking about ocean acidification as a problem. And that's a good thing to remember about some of these techniques, too, that anything you do just to control the temperature in the atmosphere does nothing for ocean acidification. Ocean acidification keeps going and going and going. And then you're mentioning, well, let's dump more in the ocean. Yeah, exactly. That's going to make the problem worse. Now, ultimately, the CO2 winds up mostly in the ocean anyway. So, you know, eventually, if we keep burning fossil fuels, it's going to go into the ocean. It's going to keep acidifying. But it's a great point that these things that affect temperature, radiation balance, don't do anything for CO2. I actually heard a proposal at this workshop in March I went to. Somebody's thinking of basically putting you know, it's acidifying, so they're thinking of grinding up rocks and sprinkling them in the ocean to try to kind of combat ocean acidification, at least around coral reefs, or I mean, this is the stage some of the thinking has got to, is if people are very much feeling this is an emergency, they're thinking, what can we do to save different parts of the Earth's ecosystems? And can we possibly reverse this acidification? In my mind, it seems pretty tough, pretty daunting task. I mean, considering the scale at which, how big the ocean is, you know, and how much CO2 we're putting in. So, but that's a great point about acidification. All right, I wanted to throw in a little bit of policy discussion. I know you guys I think you're mostly science teachers, right? Is that right? But, you know, the policy questions come up. This is a cartoon from a person just on their blog, and you can't read all the little details, but it's kind of the mad scientist here, geoengineering the planet. We will use chemicals, particles, and other schemes to stop direct sunlight from reaching the Earth. Let the public money flow and more experiments begin. And, you know, it's kind of poking at a lot of the agencies and experiments that are already out there, kind of critically, obviously. critical of this idea. Geoengineering, medicine chest, all the different things that could be used, space methods, space mirrors, chaff, liquid propane, ocean fertilization. Some groups in civil society are starting to organize against geoengineering already, saying this is just not, this is crazy. I mean, why do we want to do this? What's surprising to me is how many of my colleagues, like very well-renowned scientists, are really contemplating this idea. And that's surprising to me, because to me, I'm still on the, oh my gosh, this sounds a bit crazy thing, some of these ideas. But I think it probably, some of my colleagues are just so concerned about climate change and thinking we are not going to solve this problem in the way of like, let's reduce our energy or let's change our fossil fuel use to other kinds of energy and these kinds of things. They're just saying we are going to get to the stage potentially where we need something that can work quickly to prevent basically major catastrophic damage. So that's where people are coming from when they're going to these kinds of ideas. Even though people have said, well, if we change the albedo, if we put particles in the atmosphere, for example, we might change the Asian monsoon. Now, there's like a couple billion people who live on the rainfall, patterns of the Asian monsoon. If that really happened, that would be catastrophic for people living in that region. Which brings me to the final point I want to make about geoengineering. This is just a world map here, but the biggest challenge I see is not technical for geoengineering. It's actually a governance challenge. Who's going to decide it's okay to change the climate of the planet? We can't decide even on mandatory targets in Copenhagen or in other kinds of climate policy processes. Russia might say, we'd love it to have it be a few more, a little bit warmer because our crops would grow better. We'd love to do that. Or, some other country might say, we just think this is our problem. We're just going to go ahead and put stratospheric aerosols up there and try and cool it, do our thing on our own. I mean, it's very easy for a country to launch a bunch of airplanes and put stuff out in the atmosphere. No one's, it's even over your own airspace. I mean, nobody could stop that really. So I think that or then the converse, trying to decide as a group, as a whole planet, how to manage the temperature essentially. I think it's an amazing governance challenge, and considering how well we do with some of the other governance challenges we've had, I'm pessimistic about that. Maybe though an emergency situation, maybe that would make it come to the fore, and people would be very, very easily, they'd come to some kind of agreement. But it seems to me that people are already thinking about this in the foreign policy realm, about like rogue states doing geoengineering or unilateral geoengineering, things like that. And then on the research side, scientists are saying we need rules. We need to be getting rules about how we can do geoengineering experiments, so that they're transparent and open to the public in the sense the public understands what's going on. This is like a brave new world in terms of engineering and science, because it's at such a scale with such a potential that it really it demands, I think, much more engagement and much more involvement from civil society compared to normal science that we've been doing, that's very much more limited in space. Yeah.
And also, as we saw earlier today, that it's not going to be the governments that actually do it. They may come up with some regulations, but this is all going to be private sector investment. And we know how well that's worked in the past with the petroleum industry. And I just can't see how the free market, when it gets involved in geoengineering, is going to be beneficial.
I agree. Yeah, so her question is about the fact that basically a lot of these things could be done by the private sector. So they won't be directly, maybe even run by the government. And so how do you control those things? How do you regulate and so forth? And that's true for things like ocean fertilization. There's many small islands in the Pacific, and they have a coastal water kind of zone. It's their economic zone. So some private companies have gone and said, we'll buy up the rights to try our experiments in your part of the ocean, controlled by your economic zone, because they don't want to deal with a kind of global infrastructure, so they're dealing just with one country. Yeah, but the thing to know is that it's happening. I mean, there are private interests out there. There's money out there, as we saw. Bill Gates is already funding a cloud seeding project, and especially if carbon credits become a big market. I mean, if there's billions and billions of dollars flowing around the idea of carbon and climate, there's going to be huge incentives, even more in the private sector, to come up with schemes, and regulating that's going to be very interesting. Yeah, question. You. Yeah.
Okay. Ironically, when you keep mentioning it, I evacuated Mount Pinatubo. I was in the Philippines at the time, and that entire way of life where I lived was destroyed. And we still today, how many years later, talk about the effects that that volcano had. And that was a naturally occurring incident. So I lean in the very pessimistic outlook. If we start tinkering with things, how is that going to, a small effect, if we have no experience with any of this stuff, how's it going to affect on a larger scale? And you said a lot of things you're kind of pessimistic about now. How in your industry is it more common for people to be pessimistic or optimistic? Because you said some people want to go to extremes, and you're kind of surprised to see that. From your industry, since I have no idea, what is the climate, I guess?
Well, yeah, and I should say I'm at the university here, so I'm basically an outsider looking in. But I went to a conference in March, about 150 people, maybe more, about geoengineering, about that topic. And most people in the room were optimistic about, not optimistic, that's the wrong word. What was it that we used? Cautious and humility, the sense of humility of, are we really thinking about this? And I think, but there were scientists who do modeling who were saying, look, we can do this, we can figure out something. There were several private sector interests in the room who were very much interested to try their particular item or their idea. There were some other kinds of NGO type groups that were saying, hey, wait a second, exactly what you were saying, how is this going to affect people? And one of the things I haven't mentioned so far is climate justice, or issues of people who have less power in the system. If it turns out the good of the planet is served by us changing the climate in a certain way, and a group of people suffers who don't have a lot of voice in this topic, in this debate, that's a real issue of concern, that they're going to be squashed. They're going to be not able to have much of a say in what happens. So I think that, like I was trying to end up with, I think the governance and the how is this going to affect people is really that should be talked about right now. I mean, the technical stuff, I really honestly think that isn't as hard as the governance of it, and what's fair, what should we be allowed to be done, what is going to be outlawed outright, that kind of stuff. Yeah, question back there.
Well, I know that the atmosphere has no boundaries, and that, we saw during the Olympics that were held in China that China did do some seeding of the clouds to keep it from raining and doing different things. And according to the internet, the Chinese government, they've been doing these tests since 1995. 4,000 and some missiles and stuff. So, is there anything that has been done to actually identify if you can do like small issuances of changing the climate, just regionally, or are there some things that actually can do it more locally?
Well, it's a good question. So her question's about weather modification, essentially, and that's been a topic that's been around for 50 years or so. We've been trying it. The military's been trying it for decades. It's been tried. She just mentioned China and the Olympics, and it was well known that there was cloud seeding going on, trying to change the weather pattern. So yeah, certainly modifying the weather at a local scale and trying to get rain to flow differently has been around for decades, to varying degrees of success. I mean, people want it, but it's not scientifically proven how well it actually works still. I mean, it's hard to really prove. Hurricane modification, there was a time of maybe 30 years ago where people thought, let's try to modify hurricanes or stop hurricanes from forming. The issue that came out the most there was actually one of liability. If you start messing with a hurricane and then it gets worse or turns in a certain direction and hits somebody else, or something happens, can you even attribute why that happened and whose fault it was? And eventually the research kind of just died because nobody really wanted to deal with that issue of who's going to be liable if something happens as a result of this hurricane that we interfered with. So I think a lot of these same issues in geoengineering are going to be on the table. Your question about are people doing these kinds of smaller scale experiments, I haven't heard. Mostly people have been doing modeling experiments with geoengineering, and of course weather modification, which borders on this, but it's not really at the scale that they're hoping to change. So I haven't seen, now people have done, of course, forestry and those kinds of things. What they're talking about now is larger scale experiments, and no one's been doing those yet. The idea is or the issue on the table is how do you regulate those, and how do you agree that that's okay to go forward? You know, if it's big enough that it's going to have some impact on some people somewhere, or maybe on the planet, on the bios, you know, the ecosystem, that kind of thing. Yeah, so they're really right at that stage where they'd like to go out and do experiments. Other questions? It looks like my time is over, actually, so I'm not sure if, where's my hook and collar? Should I just keep going, or? Yeah, question.
I've heard there's a certain ski area of nuns that is cloud seeding. Do you know anything about that?
I don't know specifically. I'm quite sure that there are people around cloud seeding, and I know that cloud seeding is one of those things where counties have tried it, or different places have tried it, and then people accuse them of stealing the rain, and you know, because obviously it can't rain just more everywhere. If people take rain from one place, it doesn't come another place, and that's where governance comes in. That's where you actually get into fights over it and so forth. Could be, though, a ski resort could very well be, but I don't know. I don't know the answer. Any other questions? I was going to mention just carbon capture and storage. If you haven't heard about it, this is another big piece of the puzzle for any of these air capture mechanisms. Capturing CO2, you got to store it in the ground somewhere. And so trying to put it underground, either in the ocean, but underground in like aquifer storage, something like that. These are all oil well methods. We have these types of technologies available. Or, you know, they have flaws, obviously, as we've found out recently, too. But this is how you would have to, if you were going to go and capture CO2 from the atmosphere, this is another big part of it. You have to put it somewhere after you've captured it. You can't just magically make it disappear. And it's got a lot of mass. You got to figure out where to put it. So it's not a technology issue. It's more of a where can we put it underground type of issue. So those kinds of rigs are doing it as well. Okay, that's all I had in my slides. So.
All right, thank you, Lisa.
All right, thank you.